Welcome to Time to AI. I'm Jason Turpin. Today we're going to talk about, wait for it, two large language model application programming interface parameters, or LLM API parameters. Whew. They are temperature and top P. They influence the randomness and affect the creativeness of large language model responses. Let's do this, Leroy Jenkins. Before we get to those parameters, let's do a quick overview of basic large language model, or LLM operations. Large language models generate their responses by determining the next word in a sequence. This determination is based on the large language model itself, the user's input or prompt, and any words previously generated as part of the response. Let's talk through a basic prompt, say, story about a bird. A possible response for this might start like this: the, falcon, eagle, parakeet, etc. Some word. That's the randomness I'm talking about. Let's try this real quick. We're going to use GPT 3.5 Turbo and GPT 4 Turbo on Azure OpenAI services. We'll start with our prompt. First sentence of a story about a bird. We're using temperature and top P set to 1. This maximizes randomness and creativity, but we'll get to that in a little bit. And we're going to use GPT Turbo 3.5 for right now, the first time. Once there was a majestic eagle, so it looks like once may have been a better word, a first word at least, instead of the, or GPT 3.5. So I wonder what type of bird stories we would get from GPT 4 Turbo. You can immediately see that the words are more, I don't know what the word is, creative, or I don't know what the word is. The words are better for GPT 4. Also here it looks like perched would have been a better first word in my scenario. So have some examples for stories about a bird, just using the basic phrase, first sentence of the story about a bird. Anyway, circling back around to randomness, randomness can and should be viewed as creativity. Randomness leads to varied responses, which we as humans see as creativity. On to the parameters. First, temperature. Temperature adjusts the level of randomness and creativity in the language model's responses, with lower values producing more predictable and conservative text, and higher values generating more varied and unexpected outputs. So this takes a set of possible next words and mixes them up. Keep in mind that the LLM is using statistics and other methods to determine the next word, and it's not a truly random result, otherwise LLMs wouldn't be able to respond intelligibly. Moving to top P, the technical term for it is nucleus sampling. I'll leave it to the viewer to read up on that. A possible definition is that top P limits the model's word choices to a subset of the most probable options, ensuring diversity in the output while maintaining coherence and relevance to the topic. I like to think of it as a filter, limiting responses towards more likely results. Definitions are boring. Let's use a metaphor, a cooking metaphor. Temperature is how closely a chef follows a recipe. What if, for pizza, I used peanut butter instead of tomato sauce? Top P is the range of ingredients the chef considers. Will I put lettuce on my pizza? Thus ends the metaphor section of the video. Before I get to examples, let's cover what you need to know. These parameters impact randomness across LLM calls. A single call can be expressive, but variability across calls is impacted by temperature and top P. Both ChatGPT and Microsoft Copilot's conversational interfaces generally default temperature to 0.7 and top P to 0.95. These are not appropriate for code generation. For code generation, summarization, data analysis, and other situations where you want strict or formatted output, use low values. I use zeros for both. Running a prompt more than once to compare different results can be useful. When you want creative results, such as content creation or marketing copy, use higher values. I generally go with 1 for both. I treat them like a switch, creativity on or off. I haven't really had a need for nuance, whatever that means here. I go with both values as 0 or 1, depending on what I'm trying to do. And finally, these values should always be set explicitly. Now for some examples. Again, I'm going to be running against GPT 3.5 Turbo and GPT 4 Turbo. First, we're going to talk about birds a bit more, and then we'll get back to our food metaphor. So moving back over here, give me a type of bird. We're going to start with temperature 0 and top P 0 and run against GPT Turbo 3.5, so it's fast. So temperature 0 and top P 0 is the least random, the least creative. And as we see here, Blue Jay is the bird of choice for GPT-3.5 Turbo. Let's try temperature 1. So let's maximize the randomness or creativity of temperature, but leave top P at 0. Whole lot of Blue Jay. Let's switch it up to temperature 0 and top P1. And as I said, the values work in tandem, they work together. So temperature 1, top P1, hopefully we get a little bit out of Blue Jays here. There we go. One robin decided to show up. What do you know? Let's try this with GPT-4. Again, temperature 0, top P0. What's GPT-4 Turbo's favorite bird? It's the sparrow, I would say. And I'm not going to try all the combinations this time. Let's just go with top temperature and top P of 1 and see if we can get anything aside from the sparrow. There we go, the peregrine falcon. I was expecting him. There we go, a little bit more diversity in results. Let's kick those back to 0 for right now. One thing you can do, some of the models allow temperature to go above 1. Top P is generally limited, only not going to allow over 1, but temperature can go above 1. And when you do so, results can become erratic and that's extremely random is how I describe them. The results are gibberish in many cases, and we're going to try this real quick. So temperature 2, top P1, we're going to go against 3.5 for performance reasons. Let's see what happens here. And we're going to do this a couple times until I get the result I'm looking for. That's not the result I'm looking for. You know, you see it. I don't know what that means. I don't know if that's the right word for Blue Jay. It might not be. Okay, so I put brackets around it. Okay, now it's thinking. So I was giving responses very quickly before. Now ChatGPT is thinking. There we go. All right, let's take a look at this. Prompt 1, cardinal. Response 2 was a robin data array. It's not the name of a bird, I don't think. And then it goes into this bunch of incoherence. This is the danger of a temperature above 1. And I use temperature of 2 to exacerbate this result, this effect. Response 3 is a type of bird, could be a goldfinch. It's very, very laid back compared to the prior response. So, anyway, let's move on to the next set of examples. We're going to continue to use GPT 3. Actually, this is a good example of something that GPT 3.5 cannot do. I'm going to say, give me a list of 6 creative pizza toppings. Watch this. It returns a bunch of gibberish. It's returning 6 examples of something. But I don't think smoked salmon, cream cheese, and capers does a pizza make. So we're going to switch to GPT-4 for this one. And now we should get responses that'll make a little bit more sense, just a little bit. Note, temperature and top P are both 0, so this is the minimum randomness. I'm getting predictable results. I could actually predict this. I know that the sentence will result in this. Like 90% of the time. Let's crank up the temperature and see if that makes a difference. I have to say that temperature doesn't make a whole lot of difference if top P is continued to be left at 0. Let's try the opposite again. Temperature of 0 and top P of 1 this time. I don't want that pizza. Alright, so GPT-4 really likes that pizza. Let's take temperature to 1 and top P to 1. Hopefully we get some randomization in here. There we go. Mint chimichurri. Can't say that I like the concept of these pizzas, but they're certainly different and certainly more random and creative. Okay. Anyway, so the food metaphor was okay, but maybe it wasn't to your taste. It just so happens that large language models are very capable metaphor generators, and metaphors are awesome. They can provide a rich insights into complex concepts in a manner that can make understanding easier. Different angles, different concepts, different approaches. Check out Hofstadter if you want to go deep into metaphors. Let's do a quick metaphor generation example. In this case, I'm going to use Copilot Pro. And I'm going to set it to be creative. I'm going to ask it, generate 10 brief metaphor sets comparing and contrasting the large language models, parameters, temperature, and top P, and be creative. So what's it doing here? Temperature is a spice rack, adding a variety of flavors. Top P is like a sieve, filtering out less likely ingredients. Temperature is a playlist on shuffle, mixing up the music. Top P is the playlist order, playing the hits more frequently. You can see there's a variety of what I consider to be very good metaphors around those concepts that we're talking about. And it kind of gives you just different, like I said, different examples, different ideas in terms of ways to look at things. Love metaphors. They're great. So anyway, that's temperature and top P. As demonstrated, they work together, but I found that temperature has a greater influence on the results. The key takeaway, use high values for creativity, 1, for example, and low values for code generation or summarization, 0. Stay tuned for the next video, which will be a deep dive into a pure AI application, Imagine Databases. It's a simple but very powerful application, and a great demonstration of the powers of current AI models. Check the video description for related links and contact details. If you're interested in starting an AI project at your company, please reach out. Post questions in the comments. Oh, and please like and subscribe. I think I'm required to say that. Thanks, and take it easy.